Good morning, everyone. This is Obi-Wan Pez for N Simplex Pachinko. This is the first time that I'm doing a morning stream, so we'll see how it goes. We are going to be working a bit on more of the Calc 2 stuff that I was doing earlier. Today we're going to be talking about solids of revolution again, but this time we're going to be looking at the instead of the disk washer method, this is going to be the shell method, or the cylindrical shell method. Let's pull up what we had last time. So the original function we were working with was y equals negative x plus 2 pi plus sine of x in quadrant 1, and we were revolving this around the x-axis like this. This was then getting us a disk like this, which was going around the x-axis, and then give us a cylindrical disk to be able to calculate all of the in order to calculate the volume of the object that would be created by revolving this function around the x-axis. We also talked about what would happen if you did this with another function that had like a gap in the middle of it here, did not actually touch the x-axis. So we get something that looks sort of like a hollow Hershey Kiss over here. For all of that, we were going to need integration by parts to do a bunch of stuff. Unfortunately, I was being a little bit mean, I guess, and integration by parts technically does not come until the next couple of sections, but like, whatever. You need to know it eventually, and it's like pretty close by, so we'll do it. Alright, and for the washer method, we said that basically what we're going to get here is taking the integral from a to b, so from the start location to the end location, of the function value, which is going to get us a height of this individual infinitesimal rectangle, times our dx here. And then we wanted to know what the area of this circle would be as it went all the way around the x-axis. So we really needed, let me restate that, we really needed the volume of the cylinder, so it's the area of the face, pi r squared, the radius being the height of the function at that particular point, f of x, so pi f squared times dx, the height of that particular cylinder. And again, if we had a function that was being subtracted from it, like in this example over here, we would do f of x minus g of x, and that would be our radius that we have, and then you do pi r squared for that. That would get us the surface area of the washer. Hey, Keyboard Giver, how you doing? And then we can multiply by dx to get the height. So then, I mean, I was working on it a little bit, and I eventually found out that it is not going to work exactly the way we wanted it to, due to the fact that at some point, after some particular point, the value of the square root ends up actually being less than the other thing, which we wanted in the first place. So I was thinking, like, if you could split it up into cases and figure out where it is that it passes, you know, this inflection point or whatever, then we might be able to say, like, okay, from here to here, this is how it works, but then going from here to, like, here, thing that we'd then have to work on. but I don't know. I didn't have any luck on finding that particular point, except for this crazy quadratic that I said, like, let it be like y minus c, and now I have it. C is a value of a quadratic that's in terms of y, so it's a little gross. So unfortunately, no, it didn't work out quite the way that I wanted it to, but might be interesting still. Alright, any free Calculus BC courses? Not so much. So I know that there are, like, you can get the individual videos for all of the individual topics off of, you know, half of YouTube out there. The Stewart Calculus books are still the ones that are mostly used by academics, but at the same time, it might not be like the gold standard end all be all. Yeah, that's also a good question. That I'm not so sure about, unfortunately. I know there's, who is it? Man, I just blanked on their name. Hannah Fry and a bunch of them got together and created the Calc 1 course on a new platform, which is based on Masterclass. I mean, I've been seeing ads for it for the past like month or two at this point. So that one you can actually get college credit for, but you know, basically you're doing an online system with 3 different people doing all of the videos for them, and so it gives you a different perspective on um, gives you a different perspective from each of those instructors, which again is not free by any means. And due to the fact that it is like, oh, we're gonna give you college credit if you complete this course, they're probably behind some hefty firewalls. But what do I know? Anyway, um, y equals negative x plus 2 pi plus sine of x in quadrant 1. So we had this picture here. Should probably just copy off the other page, but whatever, it's fine. Oh no. All right, so this is exaggerated, so it doesn't quite work out, but whatever, it's cool. So, yeah, so getting started, personally, I like Patrick JMT. I like Khan Academy, although some other people do not. He's very much an engineer rather than a mathematician, so he does tend to look more into like the applied stuff, which again can be great for some people. I don't like it quite as much because it doesn't explain like the theory behind everything. Um, but it is definitely a place to get started. And it is free, so can't really beat the price there. Yeah, yeah. That's the other thing, is that if you wanted to, you don't have to do all of the mastery stuff. You could just watch the videos and then try out some of the like examples from a book, which again, you can go for yeah, that's going to be challenging. I'm not sure about that combination. Yeah, I don't know who specifically does like really in-depth but short videos, especially on academic content, because so many people want like something to be explained out there. I'll start looking for some recommendations. As far as the books go, you can always go to OpenStax and get like the Calc textbooks that are in there, or pre-calc or whatever. But they are more aligned to like, you know, American education system, so it's okay. Everything's written in tech. They were done by a group of math teachers who were independently doing this, like away from publishers and all that. So in that sense, I like it. They do get to explain some things the way that they want to explain it, and sometimes it doesn't quite align with like how the publisher, you know, the more popular like Stewart Calculus explains stuff, but at the same time it gets away from that, so it's a different perspective. Right, and studying the stuff is going to be important, you know, for actual education.
All right. I'll tell you the truth.
This is not going to be nice. Cool. No, I just remembered. So, what we've got here is a function that we can create for this function that we were starting with up here. And say, like, if we wanted to also rotate this around the x-axis, but we wanted to look at the slices differently. So in this particular case, we could find a function that is based on y in order to get the width of this particular rectangle at any given time. This is again the yep, it's the slice, the cross-section. There we go. This is going to be the cross-sectional area for this particular piece here. And again, this is rotated all the way around the axis. Well, now look at it. We're looking at this with this part being dx, or dy here. This is going to create a shell, or rather a cylinder, that goes this way. Have here our dy, and here our function of y. That's going to get us, again, this shell that goes all the way around. has a thickness of dy as we go all the way through, and has a height. This particular cylinder has a height that is going to be the function value. So then what we do is we stack and layer all of these things on top of each other for every single slice that we make. So there's going to be one here, there's going to be one here, one here, etc. And then this makes a stack of shells that go like this, and eventually, again, you get this nice curve to it. So this is usually called the shell method. So we're going to be taking the integral as we go on y from, I guess let's call it C to D. Here we have C, here we have D. As the, so what we want here is the volume of each of these shells. So the volume is going to be our, oi, the one day. Alright, so what we could do is take the cross-sectional area of this thing. So that would be f of y times dy, and then make it go all the way around in a circle. So that's going to be I guess technically we could also do sort of like a washer, but then it's infinitely thin. I hate memorizing formulas. This is one of the reasons why I don't remember all of these things. So, the thing I was forgetting is that we don't look at this in terms of volume, we look at this in terms of if you were to cut here and then unwrap this, this is basically one gigantic rectangle. Wow. Basically looks like a really thin candy bar. So this distance here is going to be the circumference around the end of the circle. Right, so the length of this rectangle is wrapped all the way around. This is 2 times pi times r. And then the width of this ends up being the height of the cylinder, which is f of y. Y here, you got your 2 pi r there. R, the radius, is going to be given by the height at that particular location, so that's just y. And then now that we have the surface area here, which is again going to be 2 pi y times f of y, it's 2 pi we can stick on the outside of the integral because again constants can pass right through. Then we're going to want the volume of this rectangular prism. So what do? We multiply by the height. The height of this particular thing is just going to be dy. Okay, so yes, cool. Got to make sure we get all of that stuff. So this here. The volume of this particular shell is again going to be 2 pi times the integral from c to d of f of y times dy. So in this particular case, with this particular function, this is really ugly. We're not probably going to be able to even come up with an equation, which is the inverse for the original that we had. Up here. So here, if you tried to solve for x and get a function of y, right? So x equals a function of y. Then what we've got is we bring x to the other side. So x equals negative y plus 2 pi plus sine of x. Well, now we've got to move the sine of x over, so this is going to be x minus sine of x equals negative y plus 2 pi. And I don't know of any particular function which is going to undo this. In theory, you could do a function transformation where, like, x minus sine of x is equal to u, and then you solve it in terms of this, and then you back it off and say, now let's solve it in terms of this stuff. And it's probably not very nice. Again, it's going to be ugly, it's going to be nasty, it's going to be all sorts of bad. In theory, you might be able to do something with this, but I'm not inclined to try on stream. You know, maybe I can do it, try to do some sort of transformation off stream and see if that works, but nah. So instead, what we can do is say, all right, if we wanted the volume of this particular solid of revolution, then it's much easier to do our disk method on this particular thing, right? We already did that last time. It was this thing, which again was not like super easy, but it was at least doable. We had a particular function, negative x plus 2 pi plus sine of x, that we squared and then took the integral of it and then multiplied by pi. So that was our volume. We ended up with 8/3 pi to the 4th plus 5 pi. Again, not particularly nice, but it's doable. And it gave us a value. Now, there might be, for instance, a particular function which is invertible. Let's just say if it was just sine of x. If you wanted to just do sine of x, that is also possible. We could do something like this, and or just cosine of x, because that's a nice shape. It's got something that looks actually similar to this. All right, if we had y equals cosine of x in quadrant 1, right, this is going to go down there, this is going to go down there, and again, exaggerated, but whatever. We had these values here, and we wanted to do a solid of revolution around the x-axis. Then, with this particular function, we could do either. We could do either the disk or the shell method in order to get this particular thing. It doesn't really matter. It's going to come out basically the same in either case. The shell method actually is going to be only slightly harder due to the fact that we have an extra y term. So you're going to need to do integration by parts again. So again, disk is going to end up being volume is pi times the integral of, oh, you know what, this is cosine squared, so it's technically also slightly harder. From 0 to pi over 2, we want the cosine squared of x dx. Whereas in the shell, we end up with volume is 2 pi times the integral from, here we have 0 to 1 in the y direction, of, and this is going to be x equals arc cosine of x. So this is going to be x arc cosine x dx. Again, not particularly nice, but it works. You can take the integral of arc cosine fairly easily, and x arc cosine x is just going to take, again, integration by parts to knock out the x, and then you get some other stuff in there. So again, something like this, a nice, easy function that is invertible. You can do either the disk or the washer method. Nope, sorry. Either the disk or the shell method, and it won't matter which one. They'll both work in one way or another. So here we'll do disk. Here we do washer. No. I keep getting them mixed up. I should really just call it the washer and the shell, and that's it. But anyway, this is going to be sort of my first draft for writing. As you can tell, it's going okay. Alright, now if we wanted to do this exact same function, but now we wanted to do it over the y-axis, rotated around the y-axis. So, y equals -x plus 2 pi plus sine x 1. And we rotated about the y-axis. That's going to go this way now. So this was sort of a Hershey kiss sort of thing, like that. And this one went up like that. We only want this stuff here. And again, this time we're going to rotate around the y-axis. So this way, what we're going to get is something that looks, roughly speaking, like a hat. If nothing else, Calc 2 and Calc 3 were really good for me in terms of being able to try to draw 3D figures. It didn't go very well, at least initially, but it at least got me to start thinking about how to draw 3D figures. How an orthogonal grid would be altered by something like this. Roughly speaking. So if we rotate this thing around the y-axis, it's going to look roughly like a hat. And again, if we want to look at the volume of this entire thing, we can do it in one of two ways. Either the disk washer method or the shell method. And again, in this case, it's actually going to be a lot easier if we do this in the disk method, you'll notice that we're going to have a problem because, just like before, this needs a function in terms of y. And again, for this particular function, it's not going to be very nice. So we're not going to be able to come up with a particular function which is going to solve this. Something like Wolfram Alpha would probably be able to come up with some sort of weird function that ends up coming up with it. I don't necessarily recommend, trying to look that up, because a lot of them have weird names that, don't mean anything to anyone who doesn't actually work with them. So here, if we actually do this, it's going to be in terms of the shell, and we're going to have dx going sideways, and f of x is going to be our function this way. So we can look at this in terms of the original function, f of x, or y equals. It's going to have to be a shell method, again, in order to get this. So here, this is going to be volume of the shell is equal to 2 pi times the radius is going to be from 0, we know, up to 2 pi when you plug in 0 for x. Nope, this is not. Nope. Whoops. Alright, goes from 0 out to the location out here where it hit, which again we found out last time was 2 pi. There we go. This is in terms of x, so we're going across. So if you want a little hint about which one to use, you're going to be doing disk if, really again, just call it washer. If the axis of rotation is perpendicular, to the function, to the function value line. You can call it that, Alright, and the shell is going to be when the axis of rotation is parallel to. That function value line. So here the line where we're measuring the function f of x is going to be up and down, and our axis of rotation is also vertical, up and down. So therefore, because it's vertical, this is going to be parallel, so we need the shell method in order to make this work. Again, if you want to switch and make it f of x is going side to side, make it horizontal, that's an option. F of y. That is an option. And again, for this particular function, it's just not an easy option. Potentially you can do it, I just am not going to spend that kind of time. Alright, so 2 pi times the, in this case, our radius is going to be x times f of x, which is our negative x plus 2 pi plus sine of x times dx. Okay, so this is going to be 2 pi times the integral from 0 to 2 pi of negative x squared plus 2 pi x plus x sine x dx. These are doable, right? These integrals are not too bad, all things considered. So we're going to end up with a 2 pi on the outside, and then we get a negative x squared. We take the integral, that's going to be a negative 1/3 x cubed plus 2 pi x. Take the integral is going to be 1/2 of that. Might as well write it out. 2 pi x squared plus x sine x. We're going to have to do integration by parts. So integration by parts again was when we're taking the integral of u dv. We're going to get uv minus integral v du. Again, stemming from the this is stemming from the product rule. So we have here, we're taking the if you back it off one step, you're looking at it as we can take the derivative of the product, and that's going to be equal to the derivative of certain pieces of these integrals. Anyway, it looks weird, but once you get into it, right, if you actually look at the reasoning behind it, it makes sense. If I have to convince anyone, I will eventually do it. Alright, so then here, the thing that we are going to take the derivative of is going to be x, because that's easy. So du is just dx, simple substitution there. dv is going to therefore be the sine of x dx, and therefore v is going to be equal to, take the integral of sine, it is a negative cosine of x. So, substituting into this formula here, we get the integral of x sine x dx is going to be, technically, all of it gets multiplied by dx. This is going to be u times v is x times the negative cosine of x minus integral of negative cosine x times du is just dx. And this is going to be evaluated from 0 to 2 pi. It's going to be equal to 2 pi times the quantity. Alright, so if we plug in 2 pi here, we're going to get a negative 1/3 of 2 pi cubed minus, this is going to be a 0, right? Plug in 0 into x cubed, it's going to be 0, that whole term 0. Plus, this is going to be half of 2 is 1 pi times 2 pi squared, again minus 0. This is going to be a negative 2 pi cosine of 2 pi. This is going to then be minus a negative makes plus, x is 0, so 0. Alright, and then this integral here ends up being a plus integral of cosine of x dx from 0 to 2 pi. Notationally, that should be there, but at the same time, we're evaluating it at the end, so we can argue that it's fine. Alright, so this is the integral of just cosine of x dx, which is going to be sine of x plus c, which again, that's indefinite, but this is definite, so we can ignore the c part. It's just going to end up subtracting. Alright, so this is going to be a plus sine of 2 pi minus the sine of 0, which both of these are 0 anyway, so it didn't really matter. But you need to show that at least to be like, okay, I'm taking into account these things. Alright, this is equal to, this is going to end up being 2 pi raised to the 4th power divided by negative 3, or a negative 2 to the 4th is going to be 16 pi to the 4th all over 3. This is going to be a 2 pi to the 3rd. So that's 8. Pi to the third times an extra pi here is going to be pi to the fourth, divided by 3. This is going to be cosine of 2 pi is going to be 1. So that is a minus 2 pi. These terms are combinable. I'm getting a negative. Oh, wait. Squared. But yeah, this is negative. That seems bad. Alright, where did I go wrong? Because there's probably something. And it's probably something very simple, like switching a sign somewhere. Anyway, these are like terms. That's going to be a negative 8 thirds pi to the fourth. And this is going to be a minus 4 pi squared. Just double check everything here. So I'm actually doing this on negative x plus 2 no, plus does go from 0 to 2 pi. Cool. Cool. Alright, 2 pi times the integral from 0 to 2 pi of negative x squared plus 2 pi x. plus x sine x dx. Yes, okay, I have that. Great. That's as far as Wolfram's going to show me. So, is there something? No, I mean, like the 16 pi to the fourth needs to be positive in order to end up with the answer that they have here, which is 8 pi to the fourth over 3 minus 4 pi squared. I have that. Or the denominator needs to change if I screwed that up somehow. Well, that's fun. Alright, so the second part is good. The negative 4 pi squared is fine. So that is all well and good. The problem is that right now we're having some issues with the first part. Awesome. That's not where I wanted it to be. Okay. Okay, so that is 8 pi to the fourth. Oh. Yeah, that makes complete and total sense because yeah. What'd I do? There we go. Alright. Yeah, that makes complete and total sense. There's not supposed to be an over 3 here on the 8 pi to the fourth term. I just got overzealous because there was an 8 pi to the fourth on this term over here, and apparently it would get jealous, so, you know, I have to put the over 3 on that one too. Alright, so get rid of that. So this is 8 pi to the fourth minus 16 over 3 pi to the fourth. Okay, much better. So this is going to be 24 pi to the fourth over 3. Nope, not 2 pi. 24 pi to the fourth over 3, which then 24 minus 16 is positive 8. All right. So this is how things, oftentimes we end up making all sorts of mistakes. Your teachers will do this all the time. The good ones will admit it. And the good ones will also not intend to. Although really, really good teachers can make intentional mistakes just to have you learn something. I'm not there. Anyway, this is not too bad. Again, doing the shell method on this particular function, going around the y-axis, we end up with something that we can actually use. And again, this is a completely different shape compared to what we had last time, which was going around the x-axis. It looks a bit like a Hershey Kiss just standing on its side. This looks more like a hat, so it has this nice soft top to it as opposed to the pointy side to it that we had last time. Alright.
I didn't write this one, he wrote this one.
the next part would be, what would we do if we had something that was like a function that was, let's do an easier function. So we're going to do, let's do this one first. So we're going to find the area that's between y equals x and y equals negative 2x plus 7. You know what? Let's change this slightly. Y equals x plus 1 and y equals 2x, negative 2x plus 7. And we're going to rotate this not around the y-axis. We're going to rotate this around y equals 8. Alright, so what does this look like? And again, that's going to be in quadrant 1. Alright, pretty close, not quite, but whatever. Alright, y equals negative 2x plus 7 is going to go down 2 and right 1, down 2, right 1, down 2, right 1. Nope. I mean, I could use that too, but... that's close. Like this. And... y equals x plus 1. Let's start here. Oh, nice. That goes through that point there. I have a mouse that has a free spin wheel on it, so sometimes it drifts without me noticing. This is going to be y equals x plus 1, and this is y equals negative 2x plus 7. They do have this nice intersection point at 2, 3, allegedly. Just make sure that that works. So 2 and 3 is yes, and 2 here is going to make negative 4 plus 7 is 3. Cool. So intersection point at 2, 3 like that. And this is going to be rotated around this line, y equals 8. This is going to be rotated around this axis up here. Now we could, again, deciding on how we want to do this, use our washer method, which would take this rectangle defined by both functions and then rotate it around in this vertical method. And again, that would be washer. Or we could take it in terms of shell, but you'd have to have two separate integrals. One would be over the top section here, and the other would be the bottom section here, because these are going to be two different schemes, right? They're both going to use the y-axis as part of both going to use the y-axis as part of the integral that we're going to find, but the function then becomes piecewise. So we'd have to add those two up. So in the interest of making this slightly easier, we can always say, okay, well, it's just going to be yeah, in the interest of making this easier, it's just going to be disk method or washer method for this, because we just want to have one integral. That's not going to be terribly difficult. Make sure that it's not terribly difficult when you're doing this. Because these are going to be polynomials, when you square them, it's going to also be a polynomial. And when you do the same thing for shell, it's also going to end up being a polynomial. So yeah, it's going to be basically just as hard to do the integrals in both directions. So the washer is going to be, so this gets a little interesting due to the fact that we now have something that we are measuring a distance to that is not the x-axis. So when it was the x-axis, it was just f minus g to find the distance between this length here and also the gap length. So here, what we've got is this 8 going all the way from the very top to the very bottom, like this. And the part that we want is going to be, again, f minus g. We want that distance. But then we also want to ensure that we cut out this top section here and this bottom section here. So what does that become? Well, that's going to be 8 is the entire thing. And we want to cut out the stuff that is above negative 2x plus 7. So this is going to be, oh man. See, this is why I'm doing first draft. Alright, easier. Let's cut out the stuff underneath x plus 1. So that's going to be like, take 8, we're going to subtract out x plus 1. So subtract out this y value here, and that cuts it. And then we also want to cut out the stuff that is above negative 2x plus 7. Why am I having such a hard time with this? Okay, let's start over. So the part that we, let's see, so the part that we want, if we said 8 minus parentheses negative 2x plus 7, that would cut out everything below this. And then from that, we would also subtract out or add back. We can find the negation of it. So we're going to add back all the stuff that is below this. So add back x plus 1. So now we want the negation of this in order to get the inside, because this is defining everything that is outside of our rectangle. So then what is this? This is going to be minus 8 on the end, because we're trying to find the distance from this stuff to 8. Oh man. Alright, this is a double negative here. That makes it, parentheses, negative 2x plus 7 minus x plus 1 minus 8. Alright, so we want the distance from f minus g to 8. That's what we've got here. Okay. Whew. It can take some thinking. It's okay. Alright, so this is going to be our radius here, which then we want to, again, pi r squared this thing, so pi this thing squared, and then take the integral as we go from 0 to 2 in the x direction, so dx. This is the problem with being out of practice. Alright, so we're going to then combine all this stuff and then square it. So we get pi times the integral from 0 to 2 of parentheses negative 2x minus x is going to be a minus 3x plus 7 minus 1 is going to be a 6 minus 8 is a negative 2 parentheses squared dx. This is then going to be pi times the integral of and here's the other thing, with this being a polynomial squared, you could also say, like, let the stuff on the inside here be u, and then to get du you find the integral or derivative of this stuff and combine it with dx. You don't have to, it's just another way to try and make this work a little bit nicer in your favor, so you don't have to multiply everything out. It has its pluses and minuses, so just going from 0 to 2, we're going to square this, we get 9x squared, 6 plus a 12x plus 4. Yes. Alright, take that integral, and it's going to be pi times, this is going to be 1/3 of 9 is going to be 3 x cubed plus half of 12x squared is going to be 6x squared plus 4x, evaluated from 0 to 2. So the zeros are all going to cancel out, become 0. We'll just ignore it. Volume here is going to be equal to 2 cubed is going to be 8 times 3 is 24 times pi, so 24 pi minus 0 plus 6 times 2 squared is 4, so 6 times 4 is 24 pi plus 4 times 2 is going to be 8 pi. This is 48 plus 8 is going to be 56 pi. The volume here is going to be 56 pi. Alright, and just to make sure, we can also do it in shell for the sake of completeness and to make sure we actually got the right answer. So this is going to be volume equals 2 pi integral from, this is going to be 0, no, from 1 to 3 in the y direction, and then also add 2 pi integral from 3 to 7. This one is going to be in the y direction from 1 to 3. We end up with the inverse of this particular function is y minus 1. dy, not dx. I should know better. And then also we have to multiply by y. Right, 2 pi y times f of y dy. Right, plus this thing, let's move that over. Plus 2 pi integral from 3 to 7 of parentheses. This is going to be the opposite of this one, or inverse of this one, so that's y minus 7 divided by negative 2. Y dy. Alright, volume is 2 pi times integral here is, this is y squared minus y dy. So we can take, this is going to be 1/3 y cubed minus 1/2 y squared. Evaluated from 1 to 3. Y equals. Plus 2, right. We already got the 2 pi outside, so we'll factor that out. Keep it here. Plus, this is going to be negative 1/2. Let's keep that consistent. Negative 1/2 y squared plus 7/2 y. So take that integral, we're going to take, it's going to be negative 1/6 y cubed plus a 7/4 y squared. And this one is evaluated where y goes from 3 to 7. Alright, now we just hope that everything works out the same. So, b equals 2 pi times the quantity. This is going to be 3 cubed is 27 divided by 3 is 9 minus 1/3 times 1 cubed is going to be 1/3 minus y squared here is 3 squared is 9, so minus 9/2, and minus a negative is plus. 1 plugged in here is going to be 1, so negative 1/2 makes plus 1/2 down here. Alright, looking pretty nice so far. This is going to be a negative. Plug in 7. 7 cubed is 243. Not quite. Yeah. $343. So close. Right. So 343 over 6. Minus a negative becomes plus. This is 3 cubed is 27 divided by 6. Is going to be plus 9/2. Which is nice because that gets rid of that one. Alright, this is going to be a plus 7/4 y squared here. 7 squared is 49 times 7 is 7 cubed, which is 343. Over 4 this time. Minus a y going in here is 9. 9 times 7 is 63 over 4. Trust the method. Negative 9/2, positive 9/2 is gone. This is going to be a, oh boy, maybe? Alright, let's figure out this one first. So 343 minus 63, they're both in terms of fourths. It makes it a little bit nicer to work with. 343 minus 63. 3's gone, so 340 minus 60 is going to be 280 over 4. Oops. 280 over 4, which is going to be 70. Positive 70. Seems promising. It's going to be a 9 here. A positive 1/2 and a negative 1/3 is going to be a positive 1/6 minus 343/6. So 343/6 or plus negative 343/6 minus 1/6 is going to be negative 342/6. And then we can divide this by 6 because that's going to be 7, 8, 9. Yeah, cool. So divide by 2, it's going to be 171 over 3. And negative 171 over 3 is going to be a negative 50. 3. Certainly hope so. Minus 1 by 6. Nope. No, that's the problem. It was 57. Okay. I don't know why I'm doing that. I could just literally undo stuff. Yeah, so 3 and a 21 gets us a 7 at the end. Alright, so then, yeah, we're good. Okay. I was getting worried because this was going to be too low, but then I forgot there's a 2 up front, so we're going to end up with 28 pi on the inside, I hope. Alright, so then negative 57 plus 9 plus 70 is going to be a positive 22. Well. Alright, hang on. 342 over 6 is 57. Cool. Minus 63 is 280 divided by 4 is going to be 70. Yep. So 79 minus 57 is going to be 22. Huh. Double's going to be 44. Alright, now we got to double check 2 of them in order to make sure we got the other correct. So, alright. Oh, you know what? I didn't do... I didn't do the shell around y equals 8. I did the shell around 0 again. So, if you do have something that is actually symmetric, then it could work, but in this case it is not actually symmetric, so we have to be careful here. Okay, let's try that again. So that's going to alter these in here. Is well nuts. All right. So, what is the shell radius? So, when we were looking at pi r, 2 pi r from before here. Our radius was y, so it's no longer y, it's going to be 8 minus y. Yeah. So our radius for this one. We have the original function, x plus 1. Nope. That's going to be y minus 1. It's the inverse of this. times, instead of y, this is now going to be 2 pi times the integral of f of y times 8 minus y dy. Alright, so this is the new distance that we're measuring in the vertical direction. So when we're doing the shell, we're measuring not from 0, so it's not... Yeah, right. So we get the function value minus 0 would be around 0. In this case, it would be function value minus 8, however, that would be a negative value, so then we flip it around, take the absolute value of that thing. We want the distance, we don't want the signed value for it. Alright, so we don't want the signed value, we want a positive value. 8 minus y is going to be positive, and it's going to give us the distance between 8 and y. Greater than y. Therefore, we use negative parentheses y minus 8, which is then going to be 8 minus y. Alright, when we were talking about like absolute value and how absolute value works, again, we're just changing the order of the subtraction in order to focus on letting the solution become positive. So 8 minus y here, dy. And also here, again, this was parentheses, y equals 2x minus 7, so that's y minus 7 over negative 2 times 8 minus y dy. Alright, so less convenient, but it'll still work now. 2 pi times integral as y goes from 1 to 3, 4, here we multiply these together, this is going to be negative y squared, positive 1 minus 8, no, positive 8, positive 1 is going to be a plus 9y, and a negative 8 dy. Plus 2 pi is factored out, integral from 3 to 7 of, and this fraction is going to kill me here, let's just take out a negative 1/2, make it much easier. This is going to be y minus 7, 8 minus y. So then we get a negative y squared. Here we get a positive 8y and a positive 7y is going to be positive 15y. And a negative 56 dy. Alright, now let's do this. So here we get 2 pi times the quantity. This is going to be a negative 1/3 y cubed. Boom. Plus 9/2 y squared minus 8y evaluated where y goes from 1 to 3. This is then going to switch all of our signs in here. This is going to make it a plus 1 over, this is going to be 1/2 times 1/3 is 1/6 y cubed. A negative 1/2 times 1/2 y squared is going to be 15 over 4 y squared. And then here, a negative times a negative is a positive. 56 over 2 is 28y. Evaluated, y goes from 3 to 7. Alright, 2 pi times the quantity. Here we get 3 cubed is 27 times negative 1/3 is going to be a negative 9. Minus 1 placed in is going to be a positive 1/3. Here we get 3 squared is going to be 9, so it's going to be 81 over 2. Positive. 81 over 2 minus 1 plugged in gets us just 9/2. Minus 8 times 3 is going to be 24. Plus 8 times 1 is just going to be 8. Alright, plus 7 cubed is 343 over 6. Minus 3 plugged in here is going to get us 27 over 6 or 9 over 2 again. Just like it did last time. The only difference now is that this is now going to reinforce rather than cancel out. Alright. So this is going to be 7 squared is 49. Times 15. We'll just leave it unmultiplied for a minute here. Let's see. Nothing's going to cancel out, is it? Oh well. Alright. So 49 by 15. It's going to be a minus. 49 by 15 is 735. Over 4. Minus a negative is going to be plus. 3 squared is 9 times 15 is 135 over 4. These are at least going to be nice. Alright, and then we get a plus 28 by 7 is 49 by 4 is 161.96. Minus 3 by 28 is 3 by 7 by 4. 12 by 7 is 84. 28 by 7, make sure. 196, cool. 28 by 3 is 84, cool. Always good when I get them right. Alright, so let's start at the end. 196 minus 84 is going to be a 112. Negative 735 plus a 135, we're going to subtract those two, is going to be 600 over 4 is going to be 150. Negative. Plus a 112 that we have from up here. Negative 24 plus 8 is a negative 16. Let's see. 81 minus 9 is 72 over 2 is 36. This over here and add 1/3 to negative 9/2 is going to be a, let's say this is going to be negative 27/6. So negative 27/6 plus 2/6 is going to be a negative 25/6. And 343 minus 25 is going to be 318/6, which is divisible by 6. Cool. Get a 53 between those two. which is positive 53. Here we get a 36 minus 16 is going to be a positive 20. And here we get a negative 9. Alright, this is going to be 73 minus 9 is going to make this an 64. And this here is going to be negative 150 plus 112. It's going to be a negative 38. 20. That's good. 6. 26. Am I getting 26? Because that's also going to be a problem. It's at least closer. Alright, let's go to Wolfram Alpha and just run the integrals real quick. Both done in the Y direction, so that's not a problem. Question, will it do it? Yeah, okay, we got 52 pi. So I'm willing to bet I made a mistake with the subtracting from 8-bit over here. Alright, that got 56 pi. So, there must be something wrong with one of these formulas. And again, probably the washer one. this is negative 2x plus 7 minus parentheses x plus 1 minus 8. It's also 56 pi. Let's do 8 minus parentheses x plus 1 minus parentheses negative 2x plus 7. So we're going kind of the opposite direction. That's 248 pi, so that's much, much worse. Yeah, never mind. Alright. Okay, what went wrong? So 8, all of it, minus x plus 1 cuts out the bottom. I'm just going to keep coming back to this. It's fine. It's fine. Look at the picture. 8 minus x plus 1 cuts out the bottom. And if we want to cut out this piece in between here, this is going to be subtracting the bit that is between 2x minus 7 and 8. Why am I having such a hard time with this? The distance between these is going to be 2x minus 7 minus 8, but then it's going to be the other way around, so it's 8 minus negative 2x plus 7. I don't think this is right, but this is somewhat absurd with all these parentheses in this thing. 488 pi over 3, so like closer, but no. Let's see. There's a stop here, no parentheses there. Kill them. That way. That is 24 pi. Okay, so we're kind of like honing in. Go back to the previous section here and make sure that I've got something at least reasonably accurate, but clearly I'm doing something wrong. Oh, okay. Yeah, I get it now. All right, so I was not actually following the rule here. Right, the actual washer method, where'd it go, is not is not all of this stuff all of this stuff squared. It's the individual f of x and g of x individually squared. Okay. So, it is quite possibly 52 pi then. Alright, let's fix this. This is quite possibly why I was having so much trouble. So then that minus 8 parentheses squared plus g was x plus 1 minus 8 parentheses squared dx. Alright, let's try that. So individually, these things need to be subtracted from 8 to find their individual distances, and then we end up squaring after that. That should make more sense. I hope. If not, we'll fix it again. Alright, so x is going from 0 to 2. This is going to be a parentheses negative 2x minus 1 plus 7 minus 8 squared plus parentheses x plus 1 minus 8 is negative 7 squared dx. Alright, let's try that. That's pi. Taking the, nope. Taking the integral from 0 to 2 of 4x. Alright, 2 and 2 again makes it plus 4x and plus 1 plus x squared minus 14x plus 49 dx. Alright, pi times. This is going to get us integral of 4x, oops, that's 4x squared. Integral of 4x squared is going to be 4/3 x cubed plus integral of 4x is going to be 2x squared plus x plus, we could combine this ahead of time. Probably would have been a little bit easier, but yeah, whatever, it'll work. 1/3 x squared minus 7x, no, that's third. 1/3 x cubed minus 7x squared plus 49x. Evaluated from 0 to 2. Alright, we can actually get rid of this line that's here too. So, volume here is going to be volume here is going to be pi times. This is going to be 5/3 x cubed minus a 5x squared plus 50x, evaluated from 0 to 2. That doesn't look promising. 280 divided by 3 times pi, which is again not right. Oh man, what am I doing? Alright. X minus 1 minus 8. Oh my god. Did I? Yeah, I did. Alright, so I did not subtract. Oh man. Alright, let's get into this. That's why it's very important to check your work. Alright, so I was thinking about it wrong the whole time. So, what we want to do is do the whole subtraction of these things from, right, we don't care about the x-axis at all, stop paying attention to the x-axis. It's from this point here at x plus 1 all the way up to negative 8. So then the correct integral for this, the correct distances for this, it's not going to be f minus g either down here. Let's just get rid of this. It's fine. See, this is why it's first draft. So how do we do this? We say, okay, we're going to take this amount that's going from x plus 1 and going all the way up to 8. And then we're going to cut out, hang on, change color. Okay, that's the problem. No. Okay. We'll take this amount that's going from x plus 1 and then going all the way up to 8, and then we're going to remove from it the place from whatever our upper one is here, up to 0, or up to 8. So we take the amount that's going from x plus 1 minus 8, distance between those two, and that's going to be our first face. Then we subtract from it the amount starting from negative 2x plus 7, and then subtract 8 to find that distance and square it. That's going to be our dx. That's going to be our washer method. And times pi. Oh man. Alright. Pi times. Integral here is going to be, again, we got to square all this stuff first. This is x minus 7 squared is going to be x squared minus 14x plus 49 minus parentheses. This is going to be a negative 2x minus 1. And we can, right, when we square it, negatives won't matter. It's the same as 2x plus 1. So we're going to get a 4x squared plus 4x plus 1 out of that. And integral 0 to 2 dx. Alright, pi integral 0 to 2 combine like terms. This is going to be a negative 3x squared minus 4 minus 14. Negative 18x plus 49 minus 1 is going to be 48 dx. Pi times the quantity. This is going to be a negative 1/3 x to the third is just going to be x to the third. Minus 1/2 18 is 9x squared plus 48x. Evaluated from 0 to 2. 0 is just all going to be 0, so we'll be happy with that. And pi times. This is going to be a negative 8. This is going to be a negative 9 times 4 is going to be a negative 36 plus 48 by 2. Is that 96? And a minus 44. Pi times 52. Finally. Oh my goodness. All right. Woo. All right, this is why it's really important to do out all of your problems ahead of time in the math education sphere. So, all you math educators out there, make sure you're doing your problems ahead of time, especially for Calc 2, as these are not as easy as Calc 1. You cannot just wing them. Just trust me on this. Alright, so thanks, Pretzel Rocks. R.I.P. Oh man. So generalized. Washer is going to be the integral, pi times the integral, from a to b, and then you're looking at f of x minus whatever your y value is that you're trying to get. Really, it's the rotational value. So, axis of rotation, a sub r, squared minus parentheses g of x minus a sub r squared dx. And this will also work in the y direction as well. So just be aware, right? I allowed a sub r to be either an x or a y value, whatever you feel like, it's fine. That's going to be the volume of this thing. So you can get your generalized washer doing that. Right, and then we could also do the same for the shell methods. So here we said that we were going to take our volume equals 2 pi times the integral from a to b, whatever direction we're doing here. So this is in the x direction. This is going to be so this is going to be our function f of x times. I mean, in here you want to like look at this in terms of, okay, it could be the absolute value of a sub r minus x, where, you know, asterisk figure out where this is going to be positive. Or then do this do the same in the y direction. So C to D be your function of y times axis of revolution minus y dy. Again, make sure that this thing is always going to be positive. So if it ends up that you swap it around, then so be it. That's fine. So in this particular case, 8 was our larger number, so 8 minus y ends up being our thing that we want up here. If it were the other way around and, you know, our axis of revolution was at like -2, then this would be our y value minus -2. So we want that distance, so y plus 2. So that's why I'm going to introduce the absolute value here to use that. Woo! All right. We can start in the next section at least. The next application of integrals that is often looked at is Arclength. So we're trying to find the length of some curve between A and B. What we want is what this actual length is going all the way across. So the absolute crudest way to do this, of course, is just to take a straight line that goes from A f at A to B f at B and calculate what that distance is. Obviously, this is not a good approximation for the length of that curve, but it is an approximation for the length of that curve. So naturally, we want to split this up into as many parts as we can. So if we split it up into quarters, it looks like this, and then we take this approximation, this approximation, this approximation, and this approximation as linear distances, and add them all up. And again, it can go pretty well. So we want the sum, essentially, as I goes from the initial segment 1 to the nth segment n. And we want, let's see, we want this to be distances. So how do you calculate distances? Well, this is going to be broken up as if they are, let's not do same color. These could be broken up as if they are linear distances. So pretend that this is it. This is going to be, distance 1, distance 2, distance 3, distance 4. So distance 1 is going to be equal to, if we did this as d1 squared, we could do the Pythagorean theorem. So this is going to be distance x1 squared plus distance y1 squared. Or then we could leave this as delta x1 squared, delta x2 squared. Sum them up. Therefore, d1 squared is equal to, nope, sorry, d1 is equal to the square root of delta x1 squared plus delta y1 squared. And also, we could say that we want this to be something that we're familiar with, so let this be square root of, we pull out, factor out a delta x1 squared, and this leaves behind a 1 plus delta y1 over delta x1 parentheses squared. The square root of delta x1 squared is going to be delta x1 outside, multiplied by the square root of 1 plus delta y1 over delta x1 is going to be f prime of x1, or, you know, very nearly. So I guess technically we can't say that, but it's close enough. So this is an approximation for it, at the very least. Which then, of course, all we need to do for that is to say, alright, well, take the limit as delta x becomes 0. And then what we're going to get is the total arc length here is going to be actually equal to the square root of 1 plus, oh, forgot the square. It's kind of important. Just a little. Alright, 1 plus f prime at x sub I, parentheses around that thing squared, times delta x. Which then can become the integral as we go from a to b of the square root of 1 plus f prime at x squared dx. Alright, so we're obviously not going to be able to figure out what this is exactly with, like, all sorts of crazy stuff, but for something that has little bits and pieces in it, we can make this easy by selecting specific examples, which do come out nicely. So if we did, for instance, let y equal f of x. Let f of x equal 6x to the 3 halves, for example. Alright, this may not come out exactly nice, but yeah, it'll be at least somewhat decent. F prime at x we need is going to be, take down this thing, is going to be 6 times 3 halves. 18 over 2 is 9. Times x raised to the, subtract 1 from the power is 1/2. So f prime of x is going to be 9x to the 1/2, which then we're going to square it here. So this thing squared is going to be 81. And just x. dx. We're going to find this arc length from, oh, I don't know. So x to the 3/2 power, let's go from 1 to 4. So x to the 3/2 looks, roughly speaking, like a parabola. It's going to be steeper than linear, but shallower than parabola. It's going to be a little bit more pointed at the x-axis, and here we have a 6, so that's going to make it accelerate pretty quickly. Alright, taking the integral of the square root of this stuff, again, let u be equal to 1 plus 81x. So then du is going to be just 81 dx. So we're going to have to get an 81 next to our dx. So if we let this be 81 dx times the square root, we're going to need a 1 over 81 to balance it out. Plus 81x. Integral from 1 to 4. And here we've got now the integral. We could also actually substitute in all this stuff. So this would be 1 over 81. If we substitute this in, this is just the square root of u du. As x goes from 1 to 4, but this means that we could actually plug this in and figure out the values for u to go a little bit more quickly. So when x is 1, it's going to be 81 times 1 is just 81, plus 1 is 82. So u goes from 82 up to 4 times 81 is going to be 324, plus 1 is 325. Doesn't seem that much easier, possibly isn't, but again, it's good enough. And if your calculator's doing most of the work, it doesn't really matter all that much either. So this is going to be like arc length, probably just L. So 1 over 81 times the integral of this, u raised to the 1/2 power, is going to be 2/3. Right, we're dividing by the new power, which is going to be 3/2. And then it's going to be u raised to the 3/2 power. And again, this would be a plus c, but we're doing definite integral, so we can ignore that. So we get a 2/3. U to the 3/2, evaluated from u is 82 up to 325. 1 over 81 times 2/3. Just factor that out. Multiplied by, here we have 325 raised to the 3/2 power minus 82 raised to the 3/2 power. Okay, so L is equal to, it's going to be 2 divided by 243. Multiplied by 325, we're taking the square root and cubing it. So if we want to take the square root of 325, we can take out a 25. Nice and easy. So 25 to the 3/2 by 325 over 25 is going to be 12. 13, right. So 300 is 12. So 13 raised to the 3 minus 82. Doesn't have any particularly nice. Just 2 and 41, so it doesn't have any nice factorizations. Alright, this one here, we're going to get a 5. Raised to the third power is 125 times 13 raised to the 3 halves power minus 82 raised to the 3 halves power. Right, and again, we're not going to get anything nicer than that out of this, so at this point, just using your calculator to figure out what this number is going to be would be an appropriate step. So 13 raised to the 1.5 is going to be 26.872, and there's more stuff after that, multiplied by 125 is going to be 5,859.020822. Goes on from there. Minus, this is going to be, still up in memory, 82 raised to the 1.5 is going to be a 742, so make that negative and add memory. I just completely screwed that up. I didn't even pay much attention to what that was in the first place. So, right, let me try that again. 82 raised to the 1.5 is going to be 742.541581, etc. And again, let's make that negative and add memory recall is equal to 5,120.809 3683, more stuff after that, and then all of this is still being multiplied by 2 over 243. Alright, so the overall length of this thing is going to be, L is approximately 42.14658. Way more in terms of decimals than we probably need, like 42.15 is probably close enough. And then we'll leave it there. Alright. So there's all sorts of functions that we can use for it. The easiest ones are going to end up being those that when you square them, you get something nice out. Something that's going to be perhaps not as nice, but still doable within the sphere of like Calc 2 is going to be something like, I gotta be careful how I do this. I think this is going to be okay. 1 plus the cosine of x. Or like 3. 1 plus 3 cosine x. So if I want this along, x is going from right, right? 0 to pi. Then the length of this thing is going to be equal to the integral from 0 to pi of square root of 1 plus parentheses. Then we got to find f prime at x, which is going to be take the derivative here. We get 0 plus 3 times, and then derivative of cosine is going to be a negative sign, so negative 3 sine of x. And then we're squaring it. dx. This is going to be 1 plus 9 sine squared of x dx. And then this is a prime candidate for a trig substitution. Alright, let's see if I remember how to do this. If we do triangle stuff. Alright, this is your x. You're taking, this is going to be square root of 1 plus parentheses 3 sine of x squared. Right, so basically leave it as it was before. This says that these are going to be the two legs of the triangle. So I'll let u be equal to 3 sine of x. So this is 1 plus u squared. And then yeah. So if one of these is 1, one of them is u, then we end up with 1 plus u squared. It's the sine, so I think maybe I'll use the opposite for that one. I'll see how that goes. I think actually it doesn't matter. I think we're good here. Ish. This is going to be the square root of 1 plus u squared. Okay. So then what we've got here is the sine . Maybe we don't need to use substitution. No, because we gotta get something that we can do here. All right. Oh, nuts. It's been too long since I've done these. Alright, that's what it is. Being on the right screen also helps. Alright, let's back this off. Well, this is kind of backwards to how I usually do it, because normally right? Normally this is just 1 plus x squared. So then we can determine what that is in terms of the trig substitution. But in this case, we've actually got something that's already a trig, and it's a trig squared. I might be getting myself into trouble here, so hooray. Okay, if this is 1, and this is 9 sine of x, 3 sine of x, because again, this is squared, so. And this is the square root of 1 plus 9 sine squared x. Alright, I think that we can say that 3 sine of x is equal to tangent of x, because the tangent of x here is going to be 3 sine of x over 1, which says that this whole thing up here oh man, okay. I hope I'm right. Alright, 3 sine of x equals the tangent of x. So this is going to be the tangent squared of x. Found from 0 to pi. 1 plus tangent squared of x dx is the, what is that, secant squared? From 0 to pi. I think in this case we're going to have to secant. You're going to have to split it up over pi over 2 and negative pi over 2. That part's going to flip up. That is already up. Symmetric, so we can just find twice the integral of secant squared of x dx. Oh, no, it's the integral of secant. Although absolute value. From 0 to pi over 2 ends up getting you the same as from 0 to pi. So provided that this has a finite integral length, then we're going to be all right here. So twice the integral from 0 to pi over 2 of just secant of x dx. Twice. No, that's a derivative. That's the integral. Integral of a secant. Because I never remember. One of those natural log ones. natural log. Absolute value secant x. Oops. Plus tangent x. Evaluated from 0 to pi over 2. Alright. Well, that says an infinite length, which we know is false. So I'm going to have to work on that. Oh, man. Alright. Let's look at this in terms of arc length. Whoa. Yeah, okay. This is going to require an integral that I don't know how to calculate because it requires a complete elliptic integral of the second kind. I don't think I've done that one before. Alright, so good news, I guess, is that it doesn't actually matter for arc length what this additive term is. It's still going to get you this thing in the inside here. Because we're taking the derivative of it, it gets rid of any sort of shift that occurs in it. So those are gone. Then you got to deal with all of these other things. Let me just check it here, because... Okay. literally we could change this over to be the sine function. Let's see if that makes it any better. Maybe. Square root 1 plus parentheses. This is still going to be 3 cosine now of pi over 2 minus x. But then we have to multiply by the derivative of the inside here, which is a negative. And then square it, so it doesn't really matter if it was negative or not. 0 from 0 to pi of the square root of 1 plus 9 cosine squared over 2 minus x. No, that says use a computer or calculator to approximate the value of the integral. Okay, it does say calculate though, so it seems like we should be able to do it. Really? Seems ridiculous. We're going from let's see, if we're going from 0 to pi on a cosine function, that's from top to bottom. So on a sine function, that's going to be same as bottom to top if we want. Let's try negative pi over 2 to pi over 2. And let's try excluding them this time and see if that does anything better. Probably not. No. That's interesting. Yeah, okay. So, as it turns out, this is going to give us something ugly, too. Alright, well, I hate leaving it on a down note, but Just watch out for functions like this, which are going to start getting you weird integrals here, and we'll talk more about trig substitution in one of the future videos. I don't think we'll get this pinned down because, you know, Wolfram seems to think we need some sort of elliptical integral of the second kind. At any rate, I am going to head on out and leave you in the wonderful hands of... I have absolutely no idea who's actually on now, apart from Bob Ross. Let's look at... Real quick, let's just see who's on the... got somebody doing math on spreadsheets. Could be interesting. Also check educational tag. Nope. I don't think I know how to check tags. Great, cool. Top categories. Not entirely. Okay. Well, at any rate, I am going to send on over to... let's do Malik. He's playing Elite Dangerous, and he's got pretty decent setup. He does Malik does VR. So let's head on over to Malik. Elite Dangerous is like sort of mathy, so can be. Alright, so anyway, we're gonna head on over there. I will probably be back at some point for a gaming stream. I will be doing math stream again on Wednesday night, and we'll try and do some cool stuff with maybe try to figure out Kiwi Gamers example that we had last time. We're kind of making progress on it, but maybe we need a completely different method entirely. We'll see how it goes. At any rate, this is Obi-Wan Pez for Ensign Flex Pachinko. See y'all later.